Welcome to Inverkenny Junction. Today we're going to look at the Heljan Class 20. Class 20 was built between 1957 and 1968. Originally called the Type 1, they was built by English Electric and have the 8 SVT engine. This was rated at 1000 horsepower, which was the maximum under Type 1 specification. They were originally numbered D8000 to D8199 and D8300 to D8327. Locomotives up to D8127 were built with disc head codes. After that they had head code boxes. Some of the disc head code variants were later modified to have head code boxes. None of them had train heating, so they were strictly freight only. Brakes were originally vacuum, and then later vacuum and air, and eventually air only. A total of 228 were produced, and some are still in use today. In later years they could be seen working nose to nose, coupled in pairs on merry-go-round trains. This gave them a combined 2000 horsepower and 150 tonnes in weight, so they had considerable pulling power. In Scotland a few were fitted with a through pipe for steam heating, so they could occasionally be seen working with a Class 27 on passenger work, but strictly in the summer only. The V8 engine configuration makes them sound like a helicopter on full throttle. Hence the nickname, choppers. But at tick over and part throttle they make a very distinctive chirping noise. This is due to the noise from the twin turbochargers going in and out of phase. So I've been thinking about fitting sound to this Class 20 for a while, and I've been experimenting with the SWD sound file on this little jig I've got here. It's basically just a 5XL decoder with speakers. The fact it's not connected to a locomotive is quite useful, as you can run it up and down through the various throttle settings, listening to the engine note without worrying about the locomotive moving. But I kept looking at it and I couldn't really get it to sound right. If you've watched my Class 47 video, you'll see I've just fitted twin speakers in that. There's a big speaker for the bass and a smaller one for the treble. But I didn't actually have a crossover in it as I didn't have the right components. You can connect a woofer and a tweeter in parallel. It sort of sounds okay. But the trouble is you're still putting the full bass power, for example, through the tweeter and vice versa. So this can cause distortions, and if you put in a lot more power through your bass speaker, which is typical, it's often too much for the tweeter. So it's good practice to fit a speaker crossover. So this is basically a low pass filter for the woofer and a high pass filter for the tweeter. Crossover design is a whole subject within itself and can be hugely complicated, especially for hi-fi. But the simplest type of crossover is called a first order Butterworth, and is basically just a capacitor for your tweeter and an inductor for your woofer. Calculating the crossover frequency is quite complicated, but there's various online calculators that do this for you. But anyway, if we want a crossover frequency of 400 Hz, we can use a 100 mic cap and a 1.5 millihenry inductor. So I had the cap which I fitted to the 47, but I didn't have the inductor, but I managed to find some and these came in this week. So I rigged these up here on my Class 20 test jig, and the sound was pretty good straight away. I think with the Class 20, because you've got that chirping turbo noise, which obviously needs a lot of treble, And you also need a bit of bass for the sort of chopper sound. So I think for the Class 20, the twin speaker setup is really what's needed. So now we've actually got this sounding good in our test jig, we can actually look at fitting the components to the locomotive. So we're going to be fitting the 5XL decoder, part number 58513, the passive radiator speaker, part number 50343, and the smaller speaker is part number 50332. So before we start, I have to say there's not really room in the 20 for the 5XL decoder. You'd normally fit the decoder sitting flat on top here where the original DCC blanking board was fitted. But because of the narrow body on the 20, the decoder's just too wide. There's also not really any room for this speaker either. I did think of fitting a smaller Locksound decoder, such as the Locksound 5, but it doesn't really have the current capacity to drive a twin motor loco, and the main thing is the audio output isn't really as high as the XL. So to get a good sound, you really need the XL decoder. I did originally start videoing the installation, but in the end I lost count how many times I've put things in and took them out again as they just didn't fit. But in the end I managed to get everything in, so I've just taken a few stills, so I'll just talk you through the installation. This is definitely the most difficult sound installation we've done, so if this is your first decoder fitting, I would recommend you choose something simpler first. So the decoder will fit in this slot in the chassis here, but the stay alive capacitor prevents the decoder going all the way down. So the first thing we need to do is cut that capacitor out and reposition it. We can solder on a couple of wires about 20mm long, and then reposition the capacitor on the board and fix it down with some double-sided tape. The underside of the decoder PCB will also short out on the chassis, so we need to add some insulation under the PCB. We can do this with just some plastic sheet, so just cut out a piece that fits the underside of the board and tape it on with some insulating tape. You'll see now the decoder will go all the way in the slot and fit flush with the top. The next thing we're going to do is fit the high pass filter capacitor for the tweeter. So solder a couple of wires on it and fit it down on this ledge in the chassis with some double-sided tape. Turning the locomotive over, we're going to then remove the central fuel tank and fit the small speaker underneath here. You need to solder a couple of wires on the speaker connections and then refit it into the little enclosure, and then fix that to the bottom of the fuel tank with double-sided tape. You can then refit the fuel tank. The next job is to fit the inductor, so we're going to position that in the nose of the loco. So solder a couple of wires on it and then fix it in with some double-sided tape. The final item to be fitted is the larger speaker, which we're going to fit in the roof above the decoder. So first of all, remove the fan PCB and remove the plastic securing lug. If we just fit the speaker to the roof now, the cone will fail on the top of the decoder. So we need to get the speaker to fit as flush as possible to the roof in order to maximise the clearance. So if you file down the edges of the back of the speaker, you can make it more or less the same shape as the roof. With a little bit of work you can get this so it fits really nice and snug. You'll end up filing off the edges of the connector, so what I did was solder 2 wires onto the actual connector pins for the speaker connections. Once that's done, you can fit it to the centre of the roof with double-sided tape. The fan PCB is repositioned up the far end here, and again you can fix that with double-sided tape. Once that's all done, you can connect everything up and test everything. If everything looks good, put the decoder in the slot and push it as far down as you can, and then put some insulation tape over the top to mainly keep the wires away from the cone of the speaker. Then test everything again. If it's all looking good, then you can put it all together. Thanks for watching. If you enjoyed the video, please like and subscribe.